Hello friends, welcome to this video on Chebyshev's inequality. So why do we need something called as inequality or something called as bounds? When we know the mean and variance of a given data, but we don't know what is going to be the nature of the probability function or the actual probability function the problem is following, then we can estimate the lower bound or upper bound of our required quantity using these inequalities. There are many such inequalities on bounds, and one of the most effective things which is commonly used is going to be Chebyshev's inequality. So we will see how we can apply Chebyshev's inequality to our problems which has an unknown distribution but just knows what is going to be the mean and variance of the data. First we will see on the statement of the inequality and then move on to apply it to problems. Come on. Chebyshev's inequality statement goes like, if x is a random variable which has mean e of x to be equal to mu and variance of x to be equal to sigma square, then probability of modulus of x minus mu greater than or equal to c is less than or equal to sigma square by c square. Mu represents the mean of the data and sigma square represents the variance of the data. If this is going to be so, then probability of modulus of x minus mu greater than or equal to c is less than or equal to sigma square by c square. Keep in mind c is greater than 0. We have an alternate form for this which is going to be more effective than this for application. So the alternate form is, this is my original form, probability of x minus mu greater than or equal to c. Over here, if I am going to substitute c is equal to k sigma, where k is going to be a positive number, then what will happen? This x minus mu greater than or equal to k sigma will become less than or equal to the sigma square, k square, c and c cancels off to leave you with 1 by k square. So this format seems to be much more easy to apply rather than the original one. So we will be making use of this. Not in all the cases we will be requiring a greater than or equal to value. At times we may require a less than or equal to value too. In which case the inequality just flips to take the complement value of 1 minus 1 by k square to the right hand side. Notice when this greater than is changing to lesser than, the inequality over here which is lesser than changes to greater than. Plus the quantity over here on your right hand side takes the value of the complement. Since it is probability, the complement is 1 minus of the original data. So it is 1 minus 1 by k square. So now having learned two format of the Chebyshev's inequality, one for a lesser than and the other one for a greater than, we will try to put them to use to find the bound, either a lower bound or an upper bound for our problems. Okay. So whenever we need a quantity to be analyzed for, we will have to check with the question which of these two formats coincides best and then accordingly take the correct formula. Problem number 1. A random variable x has a mean mu equal to 12 and variance sigma square equal to 9 and an unknown probability distribution. We have been asked to find the probability of 6 less than x less than 18. We will have to keep in mind these inequalities just provide us with an approximate solution. So they provide us only with an approximate solution. Only if the probability mass function or the density function is known, we will be getting the accurate solution. So what we are aiming is, or what these inequalities can provide is only approximate solution. In which case probability of 6 less than x less than 18 will be the same as 6 less than or equal to x less than or equal to 18. It is only approximate, right? So this equality being included or not is not going to make much difference to your answer, which is already an approximated value. So keep in mind this bounds or inequalities work whether you have strictly less than or greater than or less than or equal to, that doesn't matter for us. Now we will see how to find it. Now within the probability, what kind of inequality we have? We have a less than inequality. So in your two formulas, go and check which one has an less than inequality within the probability. Within the probability, here the inequality is greater than or equal to. Here it is less than or equal to. So within probability, less than is applicable over here. So we will better make use of this formula to estimate our answer. Okay. So I am going to use the second format for estimation of my answer. Now the second format says probability of x minus mu less than or equal to k sigma greater than or equal to 1 minus 1 by k square. We will note down the data which has been given to us. The data which has been given to us are, we have been given mu is equal to 12 and sigma square is equal to 9. So from over here, I will have sigma to be equal to 3. We take only the positive quantity for our estimation since we are dealing with probabilities. Okay. So now going on to this quantity, we have using Chebyshev's inequality, x minus mu is replaced as 12 less than or equal to k times of sigma is replaced as 3 is greater than or equal to 1 minus 1 by k square. So this is what I have using my Chebyshev's inequality for the given data. Now my target is to find the value of x. So I will have to balance this inequality to both sides. Keep in mind that whenever we have mod x to be less than or equal to a, you can just expand it for minus a less than or equal to x less than or equal to a, which means that whenever we have a line number which varies from minus a to a, my x can take the values to the positive range as well as to the negative range, to the limit of a and to the limit of minus a. Modulus has the habit of observing the negative sign. So we say that if I have a modulus, I can extend till minus a to plus a. So now I have a modulus which is less than or equal to 3k. In place of a, what do we have? We have 3k. So how about removing this modulus and expanding this function? I can write the lower value which is going to be minus a as minus 3k. This has to be less than or equal to the quantity inside the modulus. What is the quantity inside the modulus? X minus 12. This has to be less than or equal to the positive value of the quantity. What is the positive value of the quantity? That is going to be 3k. So now I have minus 3k less than or equal to x minus 12 less than or equal to 3k greater than or equal to 1 minus 1 by k square. Now the next target is to obtain the value of x. So the extras along with x has to be adjusted for. How to adjust? This minus 12, which is the extra portion, can be balanced to both sides of your inequality by adding them up on both sides. So when this minus 12 moves to the opposite side, it becomes plus 12. So I have probability of minus 3k plus 12 less than or equal to x less than or equal to, balance this minus 12 again to your right hand side, which gives 3k plus 12. And this is going to be greater than or equal to 1 minus 1 by k square. So now I have obtained a format where x is there in the middle and it has a lower limit and an upper limit. So now we are ready for obtaining our answer by the method of comparison. We will compare the given question with that of the obtained format of Chebyshev's inequality. Now, we have probability of minus 3k plus 12 less than x less than 3k plus 12 greater than or equal to 1 minus 1 by k square by what method? By Chebyshev's inequality. By Chebyshev's inequality. Okay, now the question asks us find probability of 6 less than x less than 18. I have a x here, I have a x here. When I am going to compare, what does our comparison mean? The left hand side over here has to be the same and my right hand side over here has to be the same. Come on, let us try to compare our right hand side. This says that 3k plus 12 equal to 18. So 3k is nothing but 18 minus 12. So my 3k is equal to 6. Hence I have k to be equal to 2. When I solve for the left hand side, I will be getting a same identical answer. You need not have to work out both the sides in your exam. It's just sufficient to go for one side alone. It is just for your convenience. I am working out both the sides and showing, but in exam, just go for one side of it. So this gives us minus 3k equal to 6 minus 12. Minus 3k equals to minus 6. So k will be equal to 2. So whether we solve for our left hand side or the right hand side, what is our answer? The answer or the value for k is 2. Hence, by Chebyshev's inequality, the 6 less than x less than 18 has to be what? Greater than or equal to 1 minus 1 by k square. So this will be 1 minus 1 by 2 square. So it is 1 minus 1 by 4. So what is the answer for 1 minus 1 by 4? This gives me the answer as 3 by 4. Hence, I obtain that the probability of 6 less than x less than 18 has to be greater than or equal to 3 by 4 using my Chebyshev's inequality.